All right, so the today's first topic is length and midpoint of a line segment. So we're going to learn to determine the length of a line segment using Pythagorean theorem. Just as a jump start, okay, like that's a way you could do it if you're given a graph. But what we really want to move towards is using this formula to determine the length of a line segment or the distance between 2 points, okay? And formulas are pretty easy to use. If you know the coordinates of the 2 points would be x1, y1, and x2, y2. You can just use that formula to find the distance between them, okay? So we'll develop it. We'll see why is that the formula for it, and then we'll practice using it. And then the midpoint of a line segment, if we got a graph, you'd be able to figure it out by figuring out where the middle is vertically and horizontally, and that's where the midpoint would be. But again, there's also a formula for it. And you can think of that formula as if we add the two x values together and divide by 2, that's the average x value. Just like if you want to find the average of 2 tests, you would add up your marks and divide by 2. Okay? So that's your average x value. And then this would be your average y value. So that's the formula, but that's what it means. Find the average x value and the average y value, put them together, and that will be your midpoint. So determine the length and the coordinates of the midpoint M of the line segments with endpoints A, -3, 7, and B, 5, -. So we're going to do it using Pythagorean theorem first, since we have a graph to go with it. So yeah. Oh, you do? I'm sorry. Everybody else has a lesson. Okay, so first thing you want to make sure you do is plot that point correctly. Okay, so I always double check them when I plot them. Especially if I'm not concentrating, it's really easy to go right instead of left or up instead of down. Okay, so from 0, -3, 7, there's A. And then B is at +5, -1. Which is here. So from 0, right 5, down 1. I have 2. Okay, so we're going to join points A and B to make this line segment. And then we're going to use Pythagorean theorem, so strategy from grade 9 to find how long it is. Now you realize you can't count them. You can't count diagonals because a diagonal is longer than a square. You already get that because of Pythagorean theorem. So what you want to do is make a triangle, a right triangle. So go down and across until you meet. And then you know there's a right angle here because you went horizontally and vertically. And you can actually just count. So you've got 1, 2, 3, 4, 5, 6, 7, 8 on that side. And then you've got 1, 2, 3, 4, 5, 6, 7, 8 also on this side. Okay? And then if you remember what the Pythagorean theorem said from grade 9, it said for a right angle triangle, which this is, c squared is equal to a squared plus b squared. But c had a special meaning. It had to be one of these 3 sides. Which side did c have to be? The diagonal, the one across from the right angle. Okay, so c in our formula has to be that side. But rather than call it C, we're going to call it AB, because that's what we're really trying to find, the distance from point A to point B, but it's still being squared. And make sure you use capitals, okay? That means, so AB, the way it's written there, means the distance from vertex A or point A to point B, okay? So that's why we use capital letters, because capital letters represent points on our grid, or vertices. And then A and B didn't matter which side we call A and which side we call B. They both also are 8. So the distance from point A to point B squared is, so 64 plus 64. Remember, that's not 16, it's 8 times 8. And then 64 and 64 is 128. But then that's squared, so to undo square, we do square root. So that means the distance from point A to point B, usually it's ends up being approximate. Get your calculator and you want to do the square root of 128. And that gives you 11.3, and the units are just grid units in this case. Okay, so just 11.3 units long. So far, so good? Okay, so determine the length. So we did length. Midpoint, we can do, I use purple here. So if we know that vertically there's 8 units, then we know that the midpoint's going to occur 4 units down. So it's going to occur across that line somewhere. Does that make sense? And if we know that it's also 4 along the bottom, we know the midpoint's going to occur along there too. So that must be the midpoint right there. Okay? So 4 units down and 4 units in must be the midpoint. And usually use capital M, yeah. Capital M for midpoint. But remember, label it from 0, 0. So that point, if I labeled it from 0, 0, would be 1, positive 1, positive 3. Okay, does that make sense? Positive 1, positive 3. So that's just using kind of like a grade 9 way of doing this question. Okay, like a little review of what we did last year. You would have been able to plot points, figure out the length of the side using Pythagorean theorem, and reason through where the midpoint would be. Okay? So now we're going to look at what's new for grade 10 with analytic geometry for this stuff. So we're going to develop this formula to find the distance between 2 points. So I'm going to put 2 points on this grid. Here, this is going to be my point A. And it's going to have the coordinates x, and so that's not an exponent, it's a subscript. So it's the same size as an exponent, but it's lowercase. So x1, kind of like when we did slope, or exactly like when we did slope, y1 is going to be that point. Okay? And then up here, we're going to put a point x2, y2. So put them in the same ballpark as me, but it doesn't matter where they are. And then take your ruler out and join them. So you've got a line segment, AB. And then with your ruler, we are going to create a right triangle. So draw across and down so that looks like you're making a right triangle here. got the diagram drawn. I'm just gonna make this so it's easier to see my diagram. Let's make this one. Okay, so here's my x-axis. So if I draw down to the x-axis right from that point, if this is the point x1, y1, then this is going to be x1 down here. Okay, so say this was the point 2, 3. I would go over 2 and up 3, which means that this point would be at 2 on the x-axis. Do you agree with that? This was a point 2, 3. Then this point would be at 2 for the x-axis. And it would be at 3 for the y-axis, so over here it would be at y1. And then same thing with this point here. So this point B, its x value would be x2. So say that was 8, then this would be 8 along the x-axis if this was an 8. And say this was a 9, then this would be y2. So now I want us to think about how we could use x1 and x2 to figure out what the distance is along this side in terms of x2 and x1. Yep.
X1?
Nope. x1 is just this distance here.
Yeah, the from x1 to x2 must be x1.
No. If this is 2, so let's put numbers here. If this was 2 and this is 8, this distance would just be 2. Do you agree? How would you think, if this was 2 and this is 8, how would you figure out the distance between them? Yep.
x2 minus x1.
Yeah, you do 8 minus 2, and that distance would be 6. Does that make sense to everybody? So this distance here is x2 minus x1. Okay? Now how about this distance here?
Yeah. Would be the same as y2 minus y1.
It would. y2 minus y1. Good. y2 minus y1. Okay, so I take that higher y value, subtract the lower y value, and I get the difference, which would be how long that side of the triangle would be. Okay? And what I'm trying to get is how long this side of the triangle is. Everyone see that? So I can use Pythagorean theorem again. So I want to know the distance from A to B. So the distance from A to B squared is going to be this distance, which is x2 minus x1 squared, plus this distance, which is y2 minus y1 squared. Okay? So that just follows the Pythagorean theorem. Does everyone see that? Okay? And then to get this by itself, so it's doesn't have the square anymore, you square root both sides. So this is going to have a big, long square root sign over top of it. And the formula, instead of calling it the distance from A to B, these could be any points. They just use a small letter d. So the distance between 2 points can be found using this formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. So that's the formula for the distance between 2 points. So now we don't even need a grid. We can just use this formula to plug in x1 and y1 and x2 and y2 and get the distance between the points. Okay, using the formula. So that's the grade 10 way of finding the distance between the 2 points. Okay there? Okay, so we're going to practice using the formula. So use the formula to find the length of the line segment in example 1, which has these endpoints. Okay, so we should end up getting 11.3. So now we're going to try to get 11.3 using the formula. So when you're given the 2 points, you're going to immediately label them x1, y1. Remember, x always comes first, and this is point 1. And x2, y2, just like last year when you were doing slope. You label the points x1, y1, and x2, y2. Okay? Then you write the formula out. So d equals big square root x2 minus x1 squared plus y2 minus y1 squared. Then we want to substitute the values in. So now it's just using a formula. Can we use this formula? So I still have my bracket. X2 is the number 5. There's a minus right in the formula, and x1 is negative 3. So I have 5 minus negative 3 squared. So make sure you understand how to get the 5. The minus that's in the formula, so this minus is this minus, and this minus is that minus. Okay? Everybody good there? And then we still have the y's to do. So plus bracket, y2 is negative 1 minus y1 is 7 squared. Okay? So first step, write the formula down. Second step, just substitute the numbers in and be careful that you're substituting them in the right spot. Okay? Now figure out the number that should be inside the bracket. So brackets first. 5 subtract negative 3 is positive 8. And negative 1 subtract 7 is negative 8. And I want you to be really sure in your mind what happens when you square a negative number. Get a positive. So negative times a negative is a positive. So when you square a negative number, you get a positive. So make sure you remember that when you're typing it in your calculator. So on my calculator, I want to get a number under there right now. So I'm going to type in 8 squared plus 8 squared. I'm not even going to bother because I know when I square a negative, I get a positive. Does that make sense to everybody? And that tells me 128. And then I just need to take the square root of 128. And now I've got that the distance, so approximately is the dot above the sign. The distance between the 2 points is approximately 11.3 units. Okay? So that's the formula for the distance between 2 points. Okay? All right, determine the distance between the points using the Pythagorean theorem and using the formula. Do you want some time just to try this one on your own? I'll pick it up? Yes? I think we should do that. Okay, so the first thing I would do is label the first point P, x1 and y1, and the second one x2 and y2. Okay? And then I would recopy down the formula. And then I would substitute the numbers in where they go. So x2 is -2. There's a minus in the formula. X1 is 6 squared. Okay? Plus y2 is -1. Minus in the formula. Y1 is 4 squared. Okay? So that's just my substituting step. I've got all the numbers in the right spot. Okay? Now I'm going to do the bracket. So I still have my big square root sign, and I get my calculator and I do -2 subtract 6. And that's -8 squared from the formula plus -1 minus 4 is -5 squared. And we know when we square a negative number, we get a positive. Okay? So make sure you don't put -64 by accident. You can go to 89 one step if you want to, but I'm just showing, really emphasize here that when you square a negative number, you get a positive. And then if you do the square root of 89, you get approximately, so dot, 9.4 units. So if we did this right, when we do it using the Pythagorean theorem, we should get the same answer, 9.4 units. Okay? So to do it using the Pythagorean theorem, we have to sketch it. So we have to plot the point P, 6, 4 in the correct spot. So from 0, 0, 6, 4 is here. That would be point P. And point Q from 0, 0 is -2, -1. Always double check you plotted your points right. It's really easy to just have a brain cramp and mix up X and Y or miscounting by 1. Okay? So there's PQ. And then you make a right triangle of it by going down and across with your right triangle. And then just counting the length of each side. 5. And 8. And then I said to use the spot below the graph. So if I want to do that, I would do PQ squared, because that's my hypotenuse, is equal to 8 squared plus 5 squared, or you could have had 5 squared plus 8 squared, doesn't matter. Hypotenuse squared, so PQ squared is 64 plus 25, which is 89. But you'd still need to square root. So using the Pythagorean theorem, we also get approximately 9.4 units. Okay. Any questions about this one so far? Get the two ways, and we're trying to move towards this way for grade 10. Okay. All right. Then there was the next question. Determine the midpoint of line segment PQ and plot it on the grid. So see if you can figure out where the midpoint would be. And then I'll show you how to use the formula to calculate it. Okay? Once you think you know where it is, see if you can figure out what the coordinates of that spot is compared with 0, 0. And then I'll ask somebody what they are. Okay, well, I'll post it after. After you finish. Okay, so lots of cool strategies for figuring out the midpoint. Does anyone think they know the coordinates of it? Compared with 0, 0? Yep.
2 and 1.5.
Yes. So the midpoint is at 2 and 1.5. What was your strategy, Susan?
I just went like 4,
4 over?
yeah, 4 over and then 2.5 down.
Good.
2.5 probably is.
So 4 over, so it's going to be along here somewhere, and 2.5, it's going to be there, and that's where they meet on the line segment. Okay? So that makes logical sense, but you won't always have a graph that you can use, so we have a formula that you can use. Okay, so this is 4 again, and this is 2 again. All right, so the formula for the midpoint says you take the two x values, add them together, and divide by 2, which is really your average x value. And it's a weird formula because it's got a comma in the middle. You're not used to seeing that. But it's because this is the formula to get a point, and a point has an x and a y. Okay? So the x value comes from using this part of the formula. So the x value for the midpoint comes from here. And the y value for the midpoint comes from here. So this is all based off knowing those 2 points right at the top of the page, which were P6, 4 and Q, -2, -1. So we have to give you the 2 points in order to use the formula. And you label them the exact same way you do for the distance formula. So here's my first point P, it's x1 and y1. And there's my second point Q, it's x2 and y2. Okay? So now I just use this formula for midpoint, average x, average y, and substituted the numbers. So x1 is 6 plus, from the formula, x2 is -2. 6 plus -2 over 2, comma, because it's an ordered pair. Y1 is 4, plus, from the formula, y2 is -1 divided by 2. Six plus -2 is 4. 4 plus -1 is 3. Divide each by 2. 4 divided by 2 is 2. And 3 divided by 2 is 1.5. So that way we calculated the midpoint using a formula rather than looking at our line segment and determining where it should be. Did we get the same as we did when we drew it in? Check. 2 and 1.5, yes. Okay? So those are the 2 formulas that we are learning this morning. Okay? Length and midpoint. Right? A freighter ship travels from grid position A 54 negative 200 to B 242 560. If one grid unit represents a distance of 1.2 nautical miles, determine how far the ship traveled. Okay. So, anyone have a strategy for this question? If I knew how many grid units it was, say I knew it was like 1,000 grid units long, how would I figure out how many nautical miles it was? Just multiply by 1.2 because it says one grid unit represents 1.2 nautical miles. So if I can figure out how many grid units long it is, I just take that answer and multiply by 1.2, and then I'll have how many nautical miles it is. Okay? So then to get how many grid units it is, we're just going to use our distance between 2 points formula. So this is x1, y1, our first point, and this is x2, y2, our second point. And this is our distance formula. So we're going to substitute those values into the formula. So we do d equals in our big square root. X2 is 242. Subtract x1, which is 54. But then there's a squared in the formula. Plus y2 is 560. Subtract y1, which is also negative. So we're subtracting a negative. Some people might want to put inner brackets around that. You don't have to, it's up to you, but make sure you squared. So then once you've got all of the four numbers in the right spot, now it's just using your calculator and your formula. So you're going to do 242 minus 54. And that's 188. But it's still being squared. Plus 560 subtract negative 200. So when you're subtracting a negative, you really add. So that's 760 squared. You should be able to type 188 squared plus 760 squared on your calculator and just get one value. 188 squared plus 760 squared is 612,944. 612,944. And then you got to square root that. Some people's calculators, you can do just like shift square root or shift square root of answer. Okay, so you don't have to retype that number in again. Oops. And you get 782.9 approximately. But that's grid units, and we want nautical miles. So we know that we have to multiply by 1.2. And now our units, and it's approximate because this was rounded, so this is also approximate. 938.4 nautical miles. And then because it's a word problem, you do it there. So therefore, the ship has traveled 938.4 4 nautical miles. So in this question, it doesn't say that you have to use the distance formula. So you have to kind of like underline that word, or when you're reading the question, if it asks for the distance, then you're using the distance formula to give you 2 points. Okay? Okay. 5A. 5B, the ship needs to be refueled at the halfway point of the journey. At what grid coordinates should the refueling ship meet the freighter? So this question doesn't ask for something specifically either, but do you know what it's asking us to calculate? Midpoint? What clue in the question tells us midpoint? Halfway point, good. So we know that it's a point, because it says a point, and we know it's the midpoint, because it says halfway, okay? So then, to get the midpoint, we use this formula, where we add the x values and divide by 2, and add the y values and divide by 2. Okay, so still you're going to base it off what you labeled the original points at the top, and still substitute in those same values, except you're adding them, and then dividing by 2. And 180. And then it's a word count. Is everybody okay with that? Yeah. So then you need to therefore the refueling ship must meet at 148, use a parentheses, comma, 108. Okay, I'm going to give you time to try the next one. Okay, so x2 is 6, subtracting the formula, -2. y2 is -1, subtracting the formula, 9. 6 minus -2 is 8. If you get a positive number, you don't need to have brackets around it. But in this case, if you get a negative number, you do need to have brackets. Okay? Because that means that you're squaring -10. This means you're just squaring the 10. Okay, if you remember back to grade 9. Brackets tell you what the base is, so if there is no brackets, your base is just the number right before the exponent. So that's, make sure if you have a negative number, you put brackets around it. And then you can enter that into your calculator. Remember, when you square a negative, you get a positive, so this is going to be 164 when you add them together. Pretty good. And then it'll be approximately 12.8, thank you. 12.8 units. So that's the distance side, okay? And it says to find the length, so I'd probably write therefore length of CD is approximately 12.8 units. If it said find the distance, I'd just leave it as therefore D equals, but it says something different, so I'd do a therefore statement. And then it says to find the midpoint. So that's the midpoint formula, comma. That's what I find hard for people using the midpoint formula, is it's weird to have a comma in the formula and people forget it. And they forget the parentheses as well. So make sure you remember this is for a point, that's why there's parentheses. And there's a comma, because there's an x value and a y value that makes up a point. Okay? So that's why the parentheses are there and the comma. So -2 plus 6 over 2. Y1, 9 plus -1 over 2. So 4 over 2. And 8 over 2, and that works out nicely to the 0.24. And then they asked for it, so I just put a therefore beside it, therefore, and then -2. Okay, any questions about that? So basically, we learned how to use two formulas today. We have to first know which one they're asking for, and then how to use the formula. Okay? Right in the last part just wants us to show that it works out if we look at it from a graphing standpoint. So I want to plot those 2 points from the last question. C was -2, 9. So there was C. And D was +6, -1, which is down here. And if I wanted to find the length, using the Pythagorean theorem, I can create a right angle triangle and count the sides. And then just use CD squared equals 8 squared plus 10 squared. CD squared is 164. Square root CD is approximately 12.8 units, which is what we got with no graph. So we're right, okay? And then we can just check our midpoint and plot it in. So it turned out to be 2, 4. So from 0, 0 over 2, up 1, 2, 3, 4. And let's check if that's right. So if that's right, if I go over 1, 2, 3, 4, and up 1, 2, 3, 4, 5 to get to the midpoint, I should go over 4 and up 5 to get to the other end point. Yes, so that's right as well. Okay, so to get from D to the midpoint, I went over 4 and up 5. So if that's actually the midpoint, I should have to go over 4 and up 5 to get to the other end point. Does that make sense? Yeah? Okay, so that is our first chunk of learning for the day. Looks like it's pretty much break time. So when you come back, you can start to practice.